disc brake has a disc that turns with the wheel. The disc is straddled by a caliper, in which there are small hydraulic pistons worked by pressure from the master cylinder. The pistons press on friction pads that clamp against the disc from each side to slow or stop it. The pads are shaped to cover a broad sector of the disc. There may be more than a single pair of pistons, especially in dual-circuit brakes. The pistons move only a tiny distance to apply the brakes, and the pads barely clear the disc when the brakes are released. They have no return springs. Rubber sealing rings round the pistons are designed to let the pistons slip forward gradually as the pads wear down, so that the tiny gap remains constant and the brakes do not need adjustment. Many later cars have wear sensors embedded in the pads. When the pads are nearly worn out, the leads are exposed and short-circuited by the metal disc, illuminating a warning light on the instrument panel. A drum brake has a hollow drum that turns with the wheel. Its open back is covered by a stationary backplate on which there are two curved shoes carrying friction linings. The shoes are forced outwards by hydraulic pressure moving pistons in the brake's wheel cylinders, pressing the linings against the inside of the drum to slow or stop it. Each brake shoe has a pivot at one end and a piston at the other. A leading shoe has the piston at the leading edge relative to the direction in which the drum turns. The rotation of the drum tends to pull the leading shoe firmly against the drum once it makes contact, improving the braking effect. Some drums have twin leading shoes, each with its own hydraulic cylinder. Others have one leading and one trailing shoe, with the pivot at the front. This design allows the two shoes to be forced apart from each other by a single cylinder with a piston in each end. It is simpler but less powerful than the two leading shoe system, and is usually restricted to rear brakes. In either type, shoe travel is kept as short as possible by an adjuster. Older systems have manual adjusters that need to be turned from time to time as the friction linings wear. Later brakes have automatic adjustment by means of a ratchet. Drum brakes may fade if they are applied repeatedly within a short time. They heat up and lose their efficiency until they cool down again. Discs, with their more open construction, are much less prone to fading. Apart from the hydraulic braking system, all cars have a mechanical brake acting on two wheels, usually the rear ones. The handbrake uses limited braking if the hydraulic system fails completely, but its main purpose is as a parking brake. The handbrake lever pulls a cable or pair of cables linked to the brakes by a set of smaller levers, pulleys and guides whose details vary greatly from car to car. A ratchet on the handbrake lever keeps the brake on once it is applied. A push button disengages the ratchet and frees the lever. On drum brakes, the handbrake system presses the brake linings against the drums. Disc brakes sometimes have a comparable handbrake arrangement, but because it is difficult to place the linkage on a compact caliper, there may be a completely separate set of handbrake pads for each disc.